Hi, today we're doing solving one-step inequalities lesson. So if you can write that down on the top of your note page, our standard is 7EE4. I can solve an inequality and show its solution on a number line.
For this video, you get both of us, and we're going to start by solving some basic one-step inequalities. And you'll notice in the note up top, solving an inequality is just like an equation. We're going to start the exact same way, draw a line down through our inequality, and then ask ourselves, what did they do to x? In this case, they subtracted 6, so we're going to add 6 to both sides, showing the same work we would have normally. The only difference is instead of our equal sign, we just bring down our inequality symbol here. So we got rid of our 6, so we are left with x. 4 plus 6 is 10. And then with every one of our inequalities, we're going to graph our solution down below.
That's your check.
So we put our 10, our answer is what goes in the middle, and then we number going up and down. And then we decide what kind of a circle are we going to use. This one's greater than or equal to, so we're going to use our closed circle because we do want to include the 10. But then be careful when the variable's on the right-hand side. You've got to be extra careful in how you read this. So sometimes saying it out loud to yourself, 10 is greater than or equal to x. So 10 is bigger than x, so that means our numbers are smaller.
Right, because x is less than or equal to 10 if you go the opposite way.
If you think about it, the smaller side is pointing towards the x, so that means the x is going to be the smaller numbers, so things less than 10. And then your check is done using your graph on the number line. You choose any of the numbers that you plugged in over here. So maybe we'll take our 6, and we plug it back into our inequality in place of x. And then we see, what do we get? 6 minus 6 is 0. Is 4 greater than or equal to 0? In this case, it clearly is, so we're good to go. But that's going to serve as our check in these problems.
I get a nice easy one-step equation. I've got w plus 3 is less than 6. So to undo the positive 3, we have to add a negative 3 to both sides.
Or subtract a 3.
W is now less than 3. So I am putting the 3 or the answer to that, sorry, he's numbering so nicely, inequality in the middle of my number line, making sure that 2 or 3 are above the 3 and 2 or 3 are below the 3. And now W is less than 3, so I need an open circle pointing to the left, please, sir.
So we want numbers less than 3, so we shade in the smaller numbers here.
And I'm going to pick 1 for my check. When I put it in my check, 1 plus 3 is 4. And 4 is less than 6, so it does check out. Yay, thanks for giving me an easy one.
Now let's try some other ones. So we're going to do both of the top two and then stop to have a little discussion with what we see. So I'm going to start with this one. X over negative 2, meaning x divided by negative 2 is greater than negative 6. They divided by negative 2, so I'm going to multiply by negative 2. Don't forget to take that negative with you when you multiply. Multiplying by negative 2 and dividing by negative 2 cancel out to give us a 1 or just plain x. And then negative 6 times negative 2 is positive 12. So I'm going to go ahead and graph it down here. 12, 13, 14, 15, 11, 10, 9. It's greater than, so I'm going to use an open circle. And then it says x is greater than 12, so I want numbers greater than 12. So I'm going to go this way.
It'd be more useful to use an even number like 14 in your check, though.
We'll go back to our check here after Mrs. King talks us through our next one.
Oh, really? I thought we were going right away. Okay. 4m is less than or equal to negative 24, so we're going to divide both sides by 4. To undo that multiplication, 4 divided by 4 gives you 1m is less than or equal to, do not drop that negative, so negative 6, please. 6 goes in the middle. Watch the way you number a negative number line. Haven't done that in a couple of units. There we go. Close circle, please. M is less than or equal to negative 6. Less than going away from 0, please.
All right, now let's go back and do a quick check. So I'm going to check mine here first. Mrs. King mentioned because you're dividing by a 2, you probably want to choose an even number to do your check. So I'm going to plug in a 14. 14 divided by negative 2 is negative 7. Is negative 7 greater than negative 6?
No. Negative 7 is to the left of negative 6 on that number line. So that's
in
not
this
true.
case, this one didn't work out. So we're going to come back to this one in just a second. Over here, which one do you want to check?
Negative 8, please.
Negative 8.
4 times a negative 8 is a negative 32. Is negative 32 less than or equal to negative 24?
It is. The bigger negatives are smaller. So you'll notice that we did the exact same work. We followed the exact same steps in both of these, but Mrs. King's worked out.
Yay!
Mine didn't. And it's not just because I did mine wrong. Something very important happened that we have to watch for in these problems, and this is why we're doing this lesson. Notice when I undid my division, I had to multiply both sides by a negative 2. And notice what happened to our number over here. It's flipped from being a negative to a positive. We basically flip-flopped from one side of our number line to the other. Over here, Mrs. King divided both sides by 4. She went from a negative 24 to a negative 6. It stayed on the negative side.
So the difference is that Mr. Mackenzie had to multiply or divide by a negative, where when Mrs. King undid hers, she was undoing the equation with a positive. So the negatives, when you multiply or divide, are going to change your answer because of the way that the number line works out.
So because we flip-flopped, we went from the negative side back to the positive side. We kind of flipped everything around. Here's the one thing that's different for solving inequalities than equations. When, like Mrs. King said, you multiply both sides by a negative, or if you divide both sides by a negative, a little alarm should go off in your head and say, okay, I'm flipping things around, so I need to flip the inequality symbol to go with it. So after that step, you're going to take your inequality and flip it the opposite direction. So instead of greater than, it becomes less than, and that's what you're going to
Because then you
graph.
end up graphing the other side of the number line, which makes your check true. So 14 divided by negative 2 is negative 7.
So let's check one on this side now. So which one do you want?
10.
10.
I was going to continue to go with that one, but okay. 10 divided by negative 2 is negative 5. And negative 5 is greater than negative 6 because it is closer to 0 on the number line. So if you could do us a favor, we have some notes before the next two problems. You see them on the bottom of the screen in red. So if you could write that down first before your next two problems, that would be great. If you multiply or divide both sides by a negative, you need to flip the inequality symbol, and we just explained why we are doing that.
So I'll let you take this one.
Okay, so once you have that written down, we're going to go on to example 3 and example 4 then. So if you can get all that set up and then press play again, that'd be great. All right, we got negative 3y is greater than or equal to 12. So you're dividing both sides by negative 3. So y is going to flip the signs, and 12 divided by negative 3 is negative 4. So our answer after we flip the inequality sign is y is less than or equal to negative 4.
So I number my number line. But that's where we want that little alarm bell to go off. When you're multiplying or dividing both sides by that negative, causing it to change its sign, that's where you want to flip that inequality symbol in your
And you're
answer.
going to have to take your time graphing these equations when they're in the negatives as well. So you've got y is less than or equal to negative 4. You know it's a closed circle, but this is where some of the kids get stuck. What is less than or equal to negative 4? You want to make sure that you're going away from 0.
So remember, our 0 is going to be over here. So less than, Mrs. King says, runs away from the 0, goes farther into the negatives. So that's going to be my numbers over here on the left. And we can do a quick check. Let's try negative 7. Negative 3 times negative 7 is positive 21. Positive 21 really is greater than or equal to 12.
So we're okay.
So when you do your check, you're going back to the original version, not the one where you flipped the inequality in it.
Okay, now don't jump to conclusions with the next one.
So the next one, we focus on x. Here I'm dividing by 5. So to undo that, I'm going to multiply both sides by 5. Some of us are going to go, ooh, there's a negative 6 over here, so I should be flipping my inequality. And this is where you don't want to fall for it. Ask yourself, what did I do to both sides? Well, I multiplied by a positive 5. If you're multiplying by a positive, nothing changes. We just get negative 30 is less than x. It's only when you multiply or divide by a negative do we have to flip anything.
Yeah, got to watch the undoing.
real quick filling in my number line.
So let's do negative 35.
All right, so we got an open circle because it's less than, but be careful when the x is on the right-hand side. Read it carefully. Negative 30 is less than x, meaning x is greater than negative 30.
Sorry, I skipped that.
Meaning I'm going to shade in the right-hand side of my
Towards 0.
line. I'm heading up into the positive numbers. And then we do a quick check. Let's do, I'm going to go all the way out, pretend my number line kept going, because I know I have to divide by 5, so I want to choose something that's going to divide nicely. So I'm going to do negative 25. But you can really do any number as you're moving back up towards. Negative 25 divided by 5 is negative 5. So is negative 6 less than negative 5? That's true, so we are good.
Okay, you've made it. Have a good night.